Hi, this is Mrs. Boykin, and we're going to talk about parent graph M behavior. We've talked about M behavior in the past with polynomials, whether it be an x squared, x to the third, etc. And we typically describe the M behavior by starting with describing what it looks like on the left. In other words, as x approaches negative infinity, we describe f of x as either pointing up towards positive infinity or pointing down to negative infinity. Then we looked at the right-hand side and discussed the behavior. As x is approaching positive infinity, f of x was either pointing up towards positive infinity or pointing down to negative infinity. But with some graphs, this may not necessarily hold true. So let's look at some examples. First, let's take a look at our standard polynomial. This is an x squared graph. And so on the left-hand side of the graph, we're going to say, change the color here so we can see this a little better. As x is approaching negative infinity on the left, f of x is approaching, and we can see this is pointing up, positive infinity, because it's pointing up. On the right-hand side of our graph over here, we're going to describe as x is approaching positive infinity, f of x is approaching, and it too is pointing up to positive infinity. And that's our typical way we have discussed M behavior. Let's take some other examples. And hopefully you recognize this is our exponential graph, and we know that our exponential graph is really hovering just ever so slightly above that x-axis, and as you can see, it starts to take off and it goes up. Okay, so on the left-hand side, we would say as x is approaching negative infinity on the left, f of x is approaching, we can't say positive infinity, the arrowhead's not pointing up. We can't say negative infinity, it's not pointing down. But what value is this line approaching? It's approaching 0. On the right-hand side of our graph, as we travel to the x-axis, we clearly see we are pointing up. So let's describe the right as x is approaching positive infinity, f of x is approaching positive infinity. Okay, so a little bit different because it's approaching 0. Let's take a look at another example. Hopefully you recognize this is your logarithmic graph, and we can see if we're going to trace this, we can see our graph is going down. However, with the logarithmic graph, we know that we have what's called an asymptote, and that's this imaginary line where x does not seem to ever cross. It just comes very, very close. If you looked in your table of values, you would see that it's getting closer and closer to -1, but it'll never go beyond that. So in this example, on the left-hand side of our graph, we would say as x is approaching, it's not approaching negative infinity, it's approaching the value of 1 because that is where my vertical asymptote is. So x approaches -1, where is it pointing? Well, we can see as we approach -1, we're approaching negative infinity. Okay, let's talk about the right-hand side. Well, as you can see, as we come up and over, it's going this direction, and as it goes farther to the right, in other words, as x is approaching positive infinity, because it will continue to go further to the right, f of x is approaching positive infinity. Now, please don't think that approaching positive infinity always has to be a sharp movement such as that, but as we move to the right, we can see that the y values are climbing. Here it is at 1, here it is at 2, here it is at 2.5. We can only assume as it's going farther to the right, it is going to get higher and eventually reach positive infinity. So not everything is clear-cut as this sharp upward turn. Let's take a look at another graph. Hopefully you recognize, according to the equation, that this is a square root graph. And it happens to be the square root of x plus 3. It's a square root graph. It too has an end. In other words, over here on the left, we can't say that it ever approached negative infinity because we can see that it ended right here at the negative 3. So we would say as x going to the left approaches negative 3, f of x is approaching, and what is it approaching? The y value of 0. So as x, if we start all the way over on the far right hand side, travel, as x approaches negative 3, f of x approaches 0. It's never going to go any further to the left, it's not going to go any further down. Over on the right hand side, as x approaches positive infinity, f of x is approaching, and again, just like our logarithmic, as we go farther to the right, it is climbing higher. It goes 0, 1, I can see it reach 2, it reached 3, and as it continues, it's only going to climb higher and higher, so eventually it will reach a positive infinity. And that was my last graph. So as you can see, in conclusion, some of our graphs will be typical. As x approaches negative infinity, you're going to decide if it approaches up or down. But then we have graphs such as our square root graph, our logarithmic graph, our exponential graph. Those aren't so cut and dry as our standard statement like we had with our polynomials. So anyways, if you need to look at another video, feel free to go to YouTube and search on end behavior of parent graphs and see if there's another teacher explaining it. Or please come to CAV Morning. Hope you enjoyed your snow days. I'll see you soon.